This is Professor Pelton. This is part 1 of chapter 1, part 2. We're doing exponent rules. So first, each of these you can prove simplistically with numbers. We're just using a and b as any real number, and m and n as any integer, or I'm sorry, natural number. So for the first one, the exponent rule, the question is why do you add exponents if they have the same base b? Well, think of it this way. If I have 2 to the third and 2 to the second, that's the same as 2, 2, 2, and 2 times 2, correct? That's the first one. That's the second one. So what I really have here is 2 to the fifth power. So we just proved why that you add exponents. Okay, you can do that with each of these. So for example, why do you subtract exponents for a quotient in the quotient rule? Well, if I have 2 to the third over 2 to the second, if I do the same thing, 2, 2, 2 over 2 and 2, each of the groups of 2 cancel out because they're 1, leave me with 2 to the first power, which basically shows me why I subtract exponents. And you can do that for each of these. So the power to power rule is multiply. And if you have parentheses, you need to distribute to all of the items inside. So if there's parentheses and it's a product, both of them get it. If it's a quotient and there's parentheses, both of them get the exponent. Okay. And keep in mind that b to the 0 is 1. Assuming that b is not 0, that's indeterminate, which we will do in calculus. If it's a negative exponent, it needs to reciprocate. So if it's a negative exponent, it needs to go to the bottom. Or if it's a positive negative exponent at the bottom, it needs to go to the top. Okay, you can put it over 1 if you want to, but it's not necessary. And if you make a negative exponent for both, they both just switch, because essentially what you would have is a to the negative n over b to the negative n, which essentially would just switches, right? Okay, so knowing these rules, let's apply them to the actual examples. Okay, so this first example, it's all multiply, so I can reorder the multiplication. So it's multiply, 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 multiply. There's no order to multiplication. So 6 times 5, x to the fourth, x to the second, y to the third, y to the seventh. Okay, so 6 times 5 is 30. Using the product rule, I add exponents. That's x to the sixth, and then I get y to the 10th. Okay. All right, the next one is the quotient rule. So 30 divided by 5 is 6. Okay. And then this is x to the 12 minus 3. And then y to the 9 minus 7, because the quotient rule is subtract, because for each one, the top and bottom, they cancel essentially. So you have x to the 9th, and then y to the second power. Okay, so that's the product rule in the first one, the quotient rule in the second one. All right, so the next one is a combination of several rules, because if there's an exponent in parentheses, you distribute to all the terms inside. So that's the first power, and that's the first power. So that's 5 to the 0 times x to the 0, right? Because power to power rule is multiply, 1 times 0 is 0. And anything to the 0 power is 1. So, the answer is 1. Okay. All right, so the next one is a negative exponent. So this is 7y to the second power over x to the fifth power. And that's as far as you can go because there's nothing like anymore to be able to cancel. Okay, so the next one is a power to a power rule, which is multiply. So I get b to the eighth power, right? Because power to power is multiply. So the next one, you have to be careful because this is to the first power. So this is negative 2, parentheses, to the fourth power, times y to the eighth power, because when you do power to a power, it's multiply, right? So keep in mind that an even number of negatives is positive. So you have what, 2, 4, 8, 16. So this is 16 y to the eighth. Okay. All right, let's scroll down to the next few. Okay, so, excuse me. If there's parentheses, you need to go apply to all of them. So keep in mind this is 4 to the first power. So power to power rules multiply. So that's x to the sixth and 4 to the third when you multiply, which gives me x to the sixth over 64. Okay. All right, next one. quotient rule. 35 divided by 5 is -7. This is x2 minus 6. And then for minus -8, because the quotient rule is subtract for exponents. So it's -7 x to -4 times y to the, it's not a very good y, that's okay, we'll fix that. 12th power, but we can't have a negative exponent in the final solution. So -7 y to the 12 over x to the 4th using the negative exponent rule, which just reciprocates to the opposite of the fraction. Okay, so keep in mind whether it's a variable or a number, constant, you're always to the first power by default if nothing's written. And this is an exponent, around parentheses needs to go to everything inside, and the power to power rule is multiply. So this is 4 to the -3 times, whoops, let me erase that a little bit there, that's not very good, x to the -6, and then y to the -3. Okay, so we can flip everything now. So I have y to the 3rd over 4 to the 3rd, x to the 6th. So I did the negative exponent rule. Let me make a better 4 than that. I think when I get to the end of the board, the smart board doesn't like it. Okay, so my final answer is y to the 3rd, 64, x to the 6th. There we go. Okay, so on the next page, there are some student problems. Pause the video and try the student problems for yourself. Okay, let's try the student problems. All right, so we're going to reorder everything because it's all multiply. The order of multiplication doesn't matter. It's commutative, right? So this is 4 times 10 times x to the 3rd times x squared times y to the 4th times y to the 6th. So that gives me 40 x to the 5th, because the product rule is add, and then y to the 10th. And again, if you don't remember one of the rules, just write them out longhand, right? Write out all 5 of the x's, all 10 of the y's. It's a very long process if you don't know the rules, but it is doable without them. Okay, next one is a quotient rule, which means you subtract the exponents. So 27 divided by 3, excuse me, is 9. And then x to the 14 minus 3. And then y to the 8 minus 5 using the quotient rule. So this is 9x to the 11th and y to the 3rd. Okay, next one. So this is 5 to the first power, which is 5. X to the 0 power is 1, because the 0 in this case is different because it only applies to the x. You have to be careful on that. It's different than the last problem. So my answer is 5. Okay, because that's a 0 exponent property. And to the 0 power is 1. Okay, let's scroll down a little bit. Do the last few. There we go. Scroll down a little bit too much. All right, negative exponent rule. So sometimes you'll see people just write it 4 to the second, but it's really 1 times 4 to the second, because this is actually going to move up to the top. But the reality is you don't need to write the 1 because it's a placeholder, 1 times anything itself, so you just get 16. Okay. All right, so this is y to the -14, because the power to a power rule is multiply, but you cannot have a negative exponent in the final answer. So that's y to the 14th on the bottom. You need to put a 1 on the top as a placeholder. You can't have a blank denominator, obvious, or numerator rather. That wouldn't make sense. Okay, so next one, again, placeholder values are 1, so 1 exponent is the placeholder value there. So you guys to go to both items inside, if there are parentheses. Whether it's division or a product, it does not matter. They share with everything. Okay, so power to a power rules multiplies. This is -4 to the 3rd, and then x to the 15th. So technically there are parentheses here because it's -3 to the negative, it's 3 to the -4th, but a negative times a negative times a negative is still a negative in this case. Okay, all right, last three. All right, so in this case, you need to put the negative somewhere. It either needs to go on the top or the bottom. With the constant is usually the best bet, okay? So now I have a power of a quotient, and it needs to go to each item. Each item really has an exponent of 1. Power to power is multiply. So this is -3 to the 4th and x to the 4th, right? Because you need to have that negative somewhere because it makes a difference, because 4 negatives is actually positive, okay? So let's see, 3 times 3 is 9, 9 and 9 is 81 over x to the fourth power. Okay. Whoops, that didn't come out very well. I don't know why that is. Okay, next one. 100 divided by 20 is 5, and then the quotient rule is subtract. So that's x12 minus 16, and then y2 minus negative 4. Okay, so I have x to the negative 4 and y to the 6th. So that's pretty good in the fact we have a negative exponent, which you cannot have in the final answer. So 5y to the 6th over x to the 4th is a sufficient answer. Okay, and lastly, again, if there's no placeholders, put them in for once. So this 2 or negative 2 applies to all terms in there. And this time I'm going to do a little bit different because it's negative. I'm going to use the rule that we stated. I can switch everything first. So this is y4 5x to the second power. Okay, so it just makes it negative deposits. I can do that before or after. In the last example, I did it last. This time I'm going to do it first. So this is y to the 8th, 5 to the second, and x to the second, because it's a power to a power's multiply. And since the power of a quotient needs to go to every item inside. So this is y to the 8th over 25x squared. Okay, that is the end of part 1.